In today's lesson, we're going to be strictly looking at the line and curve of best fit, being used only in Desmos. The line of best fit means an approximation of a straight line to represent the trend in data. If you need to pause at any point during this video, please do so because I'm just going to be listing off these definitions and you might need a second to write them down. The curve of best fit means constructing a model that represents the specific curves found in the trends of the data. The biggest difference is it's going to show a curve for this data trend, and for the line of best fit, it will show a linear line trend. How do you know how to pick between these two? Well, on Desmos, you'll know by the one with the higher R squared value they give you in your list of settings. And then on paper, it will be the one that most closely follows the trending data. When we make our own regression equations, we will always use standard form. For linear functions, that's going to be y subscript 1 approximately m times x subscript 1 plus b. And then for quadratic functions, that's going to be y1 approximately ax sub 1 to the squared power plus bx sub 1 plus c. Yes, we will need those subscripts of 1. And yes, we will need the approximation symbol instead of the equal sign. But beyond that, we've seen that before because we've seen y equals mx plus b. And we just worked with quadratics, which was y equal ax squared plus bx plus c. Those were the standard forms of each of those functions that we've seen before. We just have to add 1 to the x's, 1 to the y's, little subscript ones, and we have to put an approximation symbol instead of an equal sign. We're going to use Desmos to answer the following multiple choice style questions from the SOL. First question is, Bill rode his bike to a store 5 kilometers from his house. The table shows the distance from the store paired with the number of minutes leaving after his house. Which equation best models a line of best fit for the data? Right away, no matter where I'm given a table, I want to always put it into Desmos. So every time you see a table in the SOL, put it in Desmos. We are going to hit the little plus icon on Desmos, and it would be helpful to go to Desmos now to follow along. And we'll hit table. In the X column, I'll put the minutes because as you see, minutes are labeled with an X underneath. And in the Y column, I'll put kilometers from the store, distance from the store. And you could see we're getting closer as we're going down because we are walking towards that store. And again, kilometers from store was labeled with Y, minutes had X underneath, so that's why I put it in the respective columns. Because it said line of best fit, I'm going to put in R coding for the linear equation. So that will be y. And to get the subscript of 1, you just type in a 1 in Desmos and it will already make it a subscript. To get the approximation, you hit the shift and the button right before the number 1. That's an approximation symbol. You could call it a little squiggle. Then we have m, which will stay normal. X will need a subscript of 1. So after X, just type in the number 1 and it will automatically subscript for you. And then we need to hit Shift plus to get that plus sign and the letter B. As you see this what's coming up, the R squared I talked about earlier in the video here, being your value that is going to best correlate. You want it to be as close to 1 or as close to -1 as possible to really make sure you're fitting it to the data. The m is going to be replacing the value in front of x, our slope, and the b down here in the parameter is going to be replacing the b for our equation. So right away, I'm going to go ahead and write my equation and select the multiple choice answer that best fits it. So my equation is going to be y with an approximation, or we can change it to an equal sign, equals mx plus b, because that is the true linear function equation. We just have to type it in Desmos differently to get it to code correctly. We need to always replace the m, which is our slope, and the b, which is our y-intercept. The m is coming right from Desmos. If you see under parameters, m equals negative 0.27. I'll round to the nearest hundredth, and I'll keep my x and my equal sign and my y. And then I replace my b with what I see it's equal to in Desmos, which is a 4.86, again rounding to the nearest hundredth. As you see, in Desmos, they don't give me a value for y or x, so I'm keeping those variables. All they give me on my parameters to replace is the m and the b. The only answer that looks even close to this one is going to be C, and here's why. Because if I go even further with this equation and round these numbers to the nearest tenth, I get y equals, rounding it up, it's a 2 and 7 is higher, so that will be negative 0.03 with my variable x, and then 4.8, because the number after it is higher than 5, I round it up to 9. And that's exactly matching my example C. Here we go with the next SOL type question. The table below shows the data collected on the number of hours a group of students studied for a test and the score each student earned on the test. As you can see, we have hours spent studying and scores on tests. And I know it was oriented a little bit differently than the table above, but the X is going to be the hours spent. So the first values in our table, the first row. And then the Y will be the second row here. That's always going to happen when your table is horizontal this way. X before Y, think just like the alphabet. Based on the line of best fit is how I know I'm going to be using the y equals mx plus b, but obviously tailoring it for Desmos. What is the closest this to the score a student can obtain from studying for 4 hours? And how long did a student study if they received a 95 on the test? So I type in my table in Desmos, and then I type in that y equals mx plus b. But remember that y and x will need subscripts of 1. And Desmos does not like the equal sign. It wants us to approximate since we're approximating this data. The equation I'm going to have, so I'll go ahead and write it on down here. Y equals mx plus b. And I'm going to replace it with the parameters, the letters that they gave me to replace. They didn't give me a value for y, but they gave me a value for m of 6.5. Let's do the nearest tenth this time, so one decimal place. And then we're adding the b value they gave us. They did not give us an x value, which is going to be 72 point. Let's round to the nearest tenth, one decimal place, 8. Now we have our equation. We're going to go ahead and look at here the closest to the score a student would obtain from studying for 4 hours. So right away, this 4 is going to be representing my hours. Well, if we look back in my table, the hours was my x value. So that is going to be what I'm typing into Desmos. X is equal to 4. In Desmos, I keep my table. I keep my y sub 1, approximately mx sub 1 plus b. But underneath that all in the third line, I'm going to type what I just said. X equals 4 hours. As you see when you zoom out, or now I'm going to zoom in on my data, that X equals 4 line in green. Remember, if I toggle it off and on, you can see that's definitely the line. I'm looking to see where it meets my graph. Because you'll notice that when I click on my graph, or when we saw before, we'll get this gray dot. And this gray dot is the one I want to select, not the other green one. I want to select the gray ones to go as far in as you need to where they meet, or you could go as far out as you need to where they meet to get that gray dot to come up. When the gray dot comes up, like it just did here, see it's gray, click on it, and that is your answer, but not the whole point. We know that 4 is the hours. So after 4 hours, the result is going to be the y value. You want to answer with the opposite value that we inputted. So we inputted x equals 4. So we want to answer with the y value of 98.976. We say that y will equal 98.976, and that's going to be the score on the test, or the closest score. We can label it. Already, last part of this question is asking us, how long did a student study if they received a 95 on the test? So now we're going backwards a bit. We have the 95 score on the test. As you can see in our table, scores on tests are going to be our y value. So I now in Desmos will type y equals 95. So again, I keep my table. I keep my y sub 1 approximately mx sub 1 plus b, since it's a line of best fit question. And I now type in y equaling 95. You see a line comes up on Desmos. I'll change the color. I can hit the wheel and then click on the color to change it. That way it's different than my original line. And I'm going to zoom in or out, click and tap on my graph here until it gives me my gray dot. Not my gray dot of the X or Y intercept, but the gray dot specifically on my red line meeting up with my original best fit black line. So I click that one here. The estimation that I would get a score to 95 is going to be after the X, because again, I inputted the Y, so I want the opposite value, which is going to be my X value of this coordinate. 3.392 hours of studying will result in that score of 95. So again, we inputted our y value, so I need the opposite value, which is my x value of that coordinate. It was 3.392, and we'll label it as the x units, which I circled above here in orange, hours. Use the units that come from the x and y lines in your table. The next SOL type question is, which is most likely the equation for the curve of best fit for the relationships shown in the graph? The biggest thing here is that I notice in the directions I have curve of best fit, so I know I'm using the quadratic function from the front of my notes. So for this problem, I'm going to go ahead and see that there's no table, so no table to type in, but I can type in each of my equation answers, so I'll start with A. Notice the scale of my picture, -15 to 20. When I type A in Desmos, you'll see that I'm going to -300 to 300. So to fix that, to get it from -15 to 20, I go ahead to my little wrench icon at the top right, and I'm going to go to the x-axis. So I'm going to change it from -15 to 20. I can go up by one step too to make sure I'm going up by one here. Okay, that helps fix my line there. Let's do the same thing for the y values. So looking at my picture to best match it, I have to go from -20 to 15 on the y-axis. Remember, this is the y, and look how nicely they labeled our x-axis. So again, we go from the wrench icon top right, go down to the y-axis and change it to -20 to 15, and make sure the step is 1. Okay, that does not look like the picture here. So I'm right away going to delete that answer and try example B, try letter B. That also doesn't look like the visual in our notes, doesn't best fit it, so I'm going to delete B. I'm going to processes eliminate A and B. Now I'm going to go ahead and type in and try C. Does not look like my picture either, so I'm going to delete C. We probably can select D, but let's actually make that best guess and take a look at that. When I type in the letter D equation into Desmos, it perfectly fits with my data. It's truly showing the line the data is trending in. So I'll go ahead and select D as my answer. And we already eliminated A, B, C, and selected D here. In the last SOL type question, it's asking which equation best represents the set. The set is a bunch of points listed, so I'm going to write X then Y under each one because that's how our points are written. With these X's and Y's, I can actually make a table. So I will list all my X's in order in this table, and then I'll list all my Y's in order from left to right in this table. I'll go ahead to Desmos and do that now. Alrighty, remember to get a table, you hit the plus icon and put in table. And then I typed in my X values in order from left to right, and then my Y values in the second column in order from left to right. Remember, we can hit the wrench to adjust our axis. As you see, my X values range from -4 to 1. So I can do like -5 to 5 to really see all my data points. And then for my Y values, you see they range from like -9.1 is the lowest to the highest of zero point 0.3. So I'll go from -10 to 10, for instance, just to make sure I see all my data and my points. You can obviously zoom in or zoom out, but this top right wrench icon is a way to really get the axes to be precise. Now it said equation of best fit, so it didn't tell me if it's linear, which is y equals mx plus b, but remember we type it in y1, approximately mx1 plus b. Or it didn't tell me if it was quadratic, which would be y, type in the 1, hit the shift with the button next to your 1. AX, put a 1 right after, hit shift 6 to get it squared. Arrow over because you don't want to put the plus as an exponent. It's got to be just a plus. BX, again, anytime you have an X or a Y right after it, type 1 plus C. Now I'm looking at my two R squared values. This first R squared value is going to be 0.2769. My second R squared value is 0.9882. We can see right away that this R squared value here is higher. So I'm going to delete my purple equation and use the one in black. As you can see too, it best fits my data points that are showing up here. What I can also do is use the multiple choice in my problem to get my answer. Great SOL technique is using your answers to see which one best represents the model. I'll try by typing in example A or letter A to see if that's going to best fit my data. As you see, the line in red coming up is nowhere even close to the points, so I have to cross it out and try letter B. Looking at letter B of my multiple choice, I type that exact one in, everything, copy and paste it. And you see that really closely is near my data points. So I like that one. I'm going to keep it. I'll try C just to show you again that when I type in and C exactly as it is, it's near my points, yes, but it's not even touching one or two of them. It's completely missing them and it's not showing the trending curve of that data. An example D, just to get rid of that one as well, make sure we have the best one, which is B on the screen. The purple line that just came up is nowhere even close to my points. So I'm going to select B for this one. A great SOL testing strategy is using your answers in Desmos. Copy and paste them right in with the given problem information included first. Let's select B, and we have our answer.